What is friction force? So, today we're going to talk about friction. So the basic formula for friction force of friction is equal to mu, the coefficient of friction, times the normal force. So this mu value, just a coefficient that we put in front of the normal force, can be both for static and kinetic friction. So there's different coefficients based on the surface material, which can be for the kinetic friction factor or the static friction factor. And typically the static friction factor is larger than the kinetic friction factor. But in general, the force of friction is mu times the normal force. So say that there's a car sliding down a hill. So there's a car and it's sliding down a hill in this direction. The friction force is always acting in the opposite direction as the movement in order to counteract this. So this car has some weight, and a component of that weight is down the hill, pulling it down the hill. Now it has to have a force, so there's a component of the weight that's an acceleration in this direction. But if this car is to stay on the hill without accelerating, it needs to have a friction force in the opposite direction, the same magnitude as the force in the direction down the hill. Just for simplicity, I usually define the x direction and the y direction as so, in accordance with the incline. So, typically the static friction factor is a lot larger, and the static one means that it's just not slipping, no slipping. But the kinetic one means that it is slipping or sliding. So I just like to think of it of a tire. If the tire and the ground, if it's not turning and it's just sliding along, say that the brakes are locked and the wheel is locked in place and it's just sliding along, rubbing, that is slip. That would be slipping. But if it is just rolling like normal, say it's just rolling, there's no skidding happening, skidding or slipping, that means it's just static friction that we use. So if it's and it's just sliding along, leaving a skid mark, that is kinetic friction factor that we use. But if it's rolling, we use the static, because the wheel is turning around and it's never skidding. It just keeps turning. And additionally, you'd use the static one if it was just not turning at all and it's just on this incline like this, and the wheels aren't turning and it's not skidding, then we'd also use static because it's not moving. And friction is just a resistance to motion, typically. So if something is moving in this direction, the friction force has to be moving in this direction. So say an airplane is flying along in this direction. Flying in that direction, the air drag would be in the opposite direction, acting on the plane itself because of the air. And in the same way, when two surfaces are sliding against each other, those surfaces, there's a friction that exists between them. If you rub your hands together, you can feel some heat where the friction, where the kinetic energy of your hands is being converted into heat because of friction. And friction depends on the surface. So if this surface, it comes into contact with this surface, there's a certain mu value that exists when these two surfaces are in contact with one another. And that may vary depending on the surface. And really, you can look into some tables for typical values for wood or other surface materials, but oftentimes you test and you experiment to find out what the mu value is. And if you remember, the normal force is just the force perpendicular to the surface. So if there's a person standing right here on a horizontal platform, the normal force is just up. So their weight, as you remember, would go down, but the normal force is directly upward because it's perpendicular to this surface. But in the case of the car that we showed, it's a little bit more complicated. The gravity is still down, but the normal force is in this direction because it's perpendicular to the incline right here. And additionally, if this car is standing still on this hill, there's also a little bit of friction right here to make the forces in equilibrium. And we typically will sum the forces in the x and y direction, and sum the forces in the x direction. Both of those are equal to 0, assuming it's not moving, or I guess it's not accelerating. It could be moving at a constant velocity, but it can't be accelerating in this case, given our assumptions. So, friction in general.